Hello guys, good evening everyone, and welcome back to 360DigiTMG's domain analytics program. Previously, we have discussed, about 2 weeks ago that we have discussed the web and mobile analytics, and previous to that, we have discussed about healthcare analytics, and now we have come up with transportation when it comes to data analytics in transportation domain. So, like you have already know, data science, irrespective of any domain, it covers variety of domains. Over in 360DG itself covering over 56 plus domains. So it is one of the domain that we are. Now I'm handling the transportation in domain. Domain is transportation. Yeah, before getting into that, we can see what are the agenda we'll be having when it comes to transportation. So it is a eight days program, similar to the previous one, web and mobile analytics domain. So first, we will be discussing about where exactly we can apply the domain, the machine learning algorithms or AI when it comes to transportation. What are the applications? How can we improve the transportation, industry? How can we reduce the cost? How can we improve the ROI, that is return on investment? So all those things we'll see, and where exactly we can apply the machine learning, when it comes to transportation, that we'll see. That is an application that is very first day, and then we will be having the CRISP ML methodology, that is on second day, and CRISP ML methodology is cross-industry standard process. So irrespective of any domain, we'll be applying the CRISP ML methodology. That is why it is called cross-industry. So any data science project, we'll be following those phases only. We'll be having 6 phases when it comes to CRISP ML methodology, that we will look into it on the second day. And then the third day, we'll be having the exploratory data analysis and data preprocessing. So how we can process the data? I mean, whatever the data that we will be receiving, it is in the form of raw. So we can't directly use the raw form data to feed to the machine learning model. So what we will be doing? We'll be doing the pre-processing. Once the pre-processing done, and then we'll be going with exploratory data analysis, EDA. Using that, we can try to find out some inferences. So that could be exploratory data. That could be useful for the prediction. So whatever the prediction that we are going to do, or whatever the machine learning model that we are going to build. So if you find out some inferences from the data, it will be useful to do the better predictions. So those are exploratory data analysis. We'll be having different plots, unigram plots. We'll be having bigram plots. We'll be having something like that. We'll be using that. Using that, we will be bringing out some inferences from the data. And fourth day, we'll be going through data mining. In data mining, we'll be having different algorithms, something like supervised and unsupervised algorithms. What is supervised and what is unsupervised, we'll be discussing in detail when it comes to data mining. That is on fourth day. And from fifth day, we'll be taking one use case scenario when it comes to each and every. So here in data mining, that is unsupervised learning, I have taken and will be taking k-means clustering. That is one of the unsupervised learning algorithm, and we'll see one use case scenario and how can we apply the k-means algorithm when it comes to real-time places, so that we can understand where exactly we can apply the machine learning algorithms, where can we apply the unsupervised learning, where can we apply the supervised learning. So we'll be getting one idea about that, how can we apply in real time. So in unsupervised algorithm, we will be taking one algorithm, that is k-means. That is very one of the popular technique that we will be using very frequently. So we'll be taking that, and we'll see how k-means is helpful to prediction, prediction, or when it comes to segregation, how we can do it. That we will see on fourth day. And fifth day, we'll be taking KNN algorithm, that is k nearest neighbor. That is one of the supervised learning algorithm that we will be using for the classification purpose. classification, what is classification, all those things we'll be learning in detail in upcoming sessions. Just remember, on 5th day, we'll be going through KNN, K nearest neighbor algorithm. We'll be using one use case scenario, and we'll try to apply this machine learning algorithm in real case. We'll be taking one use case scenario, and then we'll be having the decision tree algorithm on 6th day. Decision tree algorithm, it is one of the popular algorithm when it comes to machine learning. That will be used for both regression as well as classification. So we'll be taking one classification algorithm, our classification use case scenario of decision tree, and we'll try to implement decision tree, and we'll also see how decision tree works. What is the principle behind the decision tree? All the algorithm that we are using. First, we'll be discussing how it is used. I mean, what is the process and what is the algorithms or mathematics that is involved behind the scenes of that particular algorithm. We'll see that first, and then we'll be using one use case scenario. And then 7th day, we'll be using the linear regression. It is also one of the popular algorithm when it comes to regression. What is regression? What is the classification? We'll be discussing when it comes to data mining. That is on 4th day. We'll be using linear regression model, and we'll try to apply in use case scenarios. We'll be taking one use case scenario, and we'll try to apply the linear regression algorithm, and we'll see what is the mathematics behind the linear regression. And then we'll be having the multi-layer perceptron on the 8th day. It is one of the ANN, artificial neural network. So we'll be using neural networks and how artificial neural network works. What is the principle behind it? Using that, we'll be doing one classification case, and we'll try to find out the different class. We'll try to classify the different classes. So these are the agenda when it comes to 8 days agenda actually. Agenda when it comes to domain analytics program. Since we are working on transportation domain, so whatever the use cases will be taking in the session, it is related to the transportation only. How can we classify, or how can we predict something when it comes to transportation? We'll be taking the data that is related to the transportation, and we try to apply in different use case scenario. So this is the 8 days agenda of domain analytics program. Now we'll get into what exactly transportation analytics, and how can we apply the machine learning, and how can we improve the transportation industry, or how can we improve the return on investment, all those things we'll see. Yeah, irrespective of any domain, it doesn't matter whether it is transportation or HR analytics or account, logistics, irrespective of any domain. The predictive analytics, how does predictive analytics works in different domains? So normally, what is predictive analytics? It is just a set of methods for analyzing the data for further forecasting. What exactly the methods? We'll be using some statistics, like very basic, like we'll be having giving just glimpse, mean, median, mode. This is also statistics, mathematics, or you can say statistics. We'll be using the mathematics or statistics, and we'll try to apply these on the data, and we'll try to bring out the inferences from the data so that we can do some prediction, or we can do some inferences. Like normally what happens if you have some business, what people ask normally, what is the average income of your business, or average profit you are gaining per year on year, or month on month, every month or every week. So these are what basic statistics will be using, and it relies on also anything that related to the machine learning algorithm or machine learning. That could be data science project. Everything is based on historical data. You should be having historical data. If you don't have any historical data, in that case, it is it is not possible to build any machine learning model. Machine learning itself, what is it? It will simply go through the data, and it will find out the pattern that is behind the data, And based on those patterns, it will come up with one logic. Based on the logic, if you deploy that particular logic or that particular model, that logic itself will be calling it as a model. When you deploy that particular model, and if you give some inputs, new inputs, based on those patterns or based on those logic, it will simply do the segregation. Or when it comes to clustering, it will simply cluster into different forms, which cluster it belongs to, which group it belongs to. Whatever the characteristics that you are giving the input as the input, those inputs belongs to which group, which similarity, which group similarity it is having. Like that, it will be doing the segregation. When it comes to classification and regression, based on that, it will simply classify into different classes. If you have just two classes, which class it belongs to, whatever the input that you are giving. So these kind of prediction will be done based on the past data. It relies on the past events of the forecast, and based on that only we will be doing the all business decisions. It's like, yeah, it is kind of how traveling in the future. What we are doing, it is we are doing the prediction for the future. It is kind of traveling to the future and and giving the predictions that we are, based on that we will be doing the business decisions. Transport, it just not for the transportation analytics. In any analytics, it will be using the same, apply the same machine learning process of using data to make prediction about the future outcomes. We'll be using the historical data, and based on the historical data, we'll be doing the prediction for the future. So without historical data, we can't do anything when it comes to data science or machine learning project. Data science or machine learning. So what are the advantages we'll be having when you know the prediction? So obviously, when it comes to let's say it's not just about the transportation, it could be anything. Let's say I have different customers. If I know who is the potential buyer of that particular product, in that case, it is, if you know that particular person can buy based on the historical data, then in that case, what you will do? You will try to push a bit more, or you will try to give some discounts. If you know that particular person going to buy, he is a potential buyer. In that case, you will try to push a bit, or you will try to give some discounts, because you know that particular person is going to buy it. If you know that particular person is not going to buy it, he just came for passing time, something like that, you don't need to push. So those are all data. How do you know? Just by looking at the historical data. So what we have to do, predictive analytics is the practice of using advanced statistics. So the basic, when it comes to machine learning algorithm, whatever the prediction that we are doing, all based on what? Advanced statistics. We'll be using different statistics and on the historical data. With that, we will be coming up with future predictions. See, if you know, what if you could predict which of your users are most likely to remain engaged? Let's say if you have some product, you have some business, and whatever the customers will be having, you know that he will be with you only. In that case, what you do? You will be ignoring that particular person, because he'll be staying with you only. And if somebody, if you already know, using the machine learning prediction, you came to know that some customers might like to churn. Churn means you might lose that particular customer. In that case, what you can do? You can come up with some customized strategies, like you can give customized discount for them, so that you don't lose those particular customers. So if you know these kind of outputs, whatever the things that are going to happen in future, according to that, you can make so many business decisions. But if you know, this is one of the classic scenario. But if you know if that particular person gonna churn, or the customer gonna churn, or he will be remain engaged with you only. So what kind of business decision that you can make? And it is one of the example. When it comes to the transportation. But if you know when that particular machine can break down, so whatever the machine that you are using in industries, but if you know at what time that particular machine going to break down, what are the business decisions that you can make? Let's say you have some production, and like lots of people are working, lots of people, mass, human resources is working on your production, and suddenly if you don't know, if you haven't applied, or if you didn't deploy the machine learning algorithm, and suddenly the main component like machine, breakdown happened. In that case, what happens? You have mass production to do, and you will be losing that production capacity, and you have mass number of people, human resources working on that particular company. In that case, everything will be disrupted, and it will be a huge disaster. In order to avoid that, what we can do, see, it is, we are losing the production as well, and you are losing the time, and you need to pay the money for those human resource that you'll be having, and you're not doing any prediction. In that case, it is a loss on both sides. To avoid that, what we can do, we can deploy the machine learning algorithm. What does machine learning algorithm do in this case? It will simply predict which, at what point that breakdown can happen, whatever the machine that we are using, at what point that particular machine can break down. If you do know that particular time, in that case you can make some alternate arrangement. So maybe you might be buying extra machine, or you might be coming up with different business business decisions that you can make, so that you can avoid that losses. How can we do that? If you have that data regarding that particular machine, previous historical data, how long that particular machine can perform. So what are the different components will be having, what effects that component will cause to the machine, and how much that particular components can influence for that particular machine learning breakdown. So if you know these kind of things, in that case you can make so many business decisions, and you can avoid so many losses. So this is where exactly we'll be using the machine learning algorithm when it comes to transportation or anything, whether when it comes to transportation, engines that we'll be using. So if that particular vehicle is going through different areas, in that case, how much damage happened to that particular machine. If it is going through like smooth roads every single day, in that case, how much life expectancy we can expect from that particular engine. And if it is going through the rough roads, in that case, how many days it can it can last, so that we can avoid the breakdown. So if you know the data of these different machines, you can easily predict, right, how long it will stay, when can we expect the breakdown in that particular machine, so that we can avoid. Let's say we are going to some long road. You are transporting some heavy machinery from one place to another place. It involves long distance, like 3,000 kilometers, 4,000 kilometers. In that case, whatever the machine or the engine, that particular vehicle that you are using, you should be knowing, you should be having idea about that particular engine details. Why? Because see, if it is traveling this much time, 3,000 kilometers, if it is heavy machinery, in that case, in case if it is, the engine breakdown in the middle, in that case, the cost will be double. In that, why? Because whatever the machinery will be having, this truck, we have to reload into another. In that case, labor involves. If you know when exactly, the condition of that particular engine, you can avoid this. Is it going to survive until this whole 3,000 kilometers? If you know that data, in that case, you can simply use those particular machine only to transport. So like that, we can avoid these kind of breakdowns in the middle. So I hope you guys have an idea where exactly we'll be using the machine learning algorithms. And when it comes to transportation, where exactly we'll be using, that we will see. Yeah, when it comes to transportation industry, see, industry has been undergone multiple changes, past hundreds of years, and nowadays we'll be in a position to use machine learning algorithms when it comes to transportation industry. It is a major breakthrough and being achieved in the form of artificial intelligence in transportation. That means artificial intelligence means it is a form of machine learning only. So whatever the end product will be having using the machine learning algorithm, we'll be calling it as AI, artificial intelligence. That could be in the form of self-driving cars for more reliability, road conditions. See what happens when you automate things. We can easily find out, how accurate that is. Like we can easily avoid the human error, whether it could be in the form of self-driving cars for more reliability, or road condition monitoring for improved safety, or traffic flow analysis for more efficiency. AI is catching the eyes of transportation. Nowadays, we'll be deploying the machine learning algorithm in transportation industry as well, so that we can improve return on investment. Indeed, the Forbes also predicted that whatever the potential we'll be having using the AI when it comes to transportation industry, it has been forecasted by 2026 it will reach by $3.8 trillion. The transportation sector already identified that the potential of AI, which we'll be using when it comes to transportation, it will be reached by $3.8 trillion by 2026. So the transportation industry, machine learning and AI when it comes to transportation industry has huge potential to catch, and we can apply the AI and machine learning algorithm when it comes to transportation. Where exactly will be applying, and how can we improve the transportation industry when it comes to machine learning when it comes to transportation, we'll see. So we have so many applications when it comes to transportation. What are those? We will see one by one. See, transportation is kind of backbone when it comes to commerce. Economy of that particular country. If you have roads and the transportation is taking less time, in that case it will be a huge boost to any economy. So if the transportation is the road transportation and the waterways are the very cheapest one. So if your road transportation is good, in that case we can easily reduce the cost when it comes to transportation. And the next we'll be having the waterways. So it is not compulsory to have waterways always. So it is, road transportation is very easily accessible to anybody. So we'll be using road transportation is very convenient, and you don't need to have anything extra. Like, some countries will be having the waterways, but it is not compulsory to have everybody have to have waterways. So waterways is one of the cheapest one, but it is not possible to have all the countries to have the waterways. And internal, if you want to go through the internal transportation, that in that case you need to have a good transportation. So the need of transportation keep growing as a result of the population growth trends. If population is growing, in that case transportation also very compulsory. New technological development and rising economics, in order to increase the economy of that particular country, in that case also you need to have good transportation. And lessening the traffic congestion. So where exactly we can use the machine learning algorithm to detect traffic congestion. If you want to avoid that particular area, in that case we can simply apply the computer vision technologies. Using that, we can simply capture the information, or drone analytics we can apply and capture that particular information, and you can pass it, which is using the Google Maps. We will be having, right, in Google Maps we are already using this machine learning algorithms. In that particular area we'll be having more congestion. It will simply tell, right, you will be having this area, this particular route, you have more congestion. If you want, you can simply go through at the route. In that route, we don't have any congestion. Something like update we'll be getting. In that area also, I mean, it is already used the machine learning algorithm, and we can improve those and enhancing the safety. So it is a very important thing. I mean, all over the world, every now and then we can see there are so many accidents, road accidents are happening. Maybe some are because of roads, and some are because of the driver carelessness, you can say, or fatigue, the sleepiness of that particular driver. So these also we can avoid using the machine learning algorithms. We can deploy some computer vision technologies to monitor that particular person, whoever driving that, and we can monitor drone analytics, and there are different computer vision technologies will be having to monitor the roads. I mean, path hole. I mean, wherever we have, where exactly we'll be having path holes. If you want to detect for that, also we can use drone analytics and different computer vision technologies. And we can use, I mean, if you deploy machine learning algorithms, in that case, we can minimize the human error and mitigating the unfavorable environmental condition. If you do know the forecast, I mean, if you use forecasting to forecast the temperature or the weather condition for the next few days, in that case, we can avoid in that particular area. I mean, especially aviation analytics, aviation. So everything is based on the weather forecasting only. If the weather is not good in the coming days, in that case, we can simply stop the whole the traveling by air, so that we can minimize the accidents. So there also we can use the transportation analytics or machine learning and maximize the energy performance. When it comes to energy performances, based on how much weight of that particular vehicle, and weight, I mean, horsepower of that particular vehicle. These are the different features we can use. Based on that, we can forecast, I mean, how much energy, I mean, how much fuel that particular engine is taking. Based on that, we can develop some particular engine that can take less fuel, and raising surface transportation productivity and efficiency. I mean, whatever the accident that we are having when it comes to surface transportation, that we can avoid by maybe using the automated machines. And like whenever you are talking about the automatic machine, that one thing that comes in your mind, that is Tesla. So completely automated. Using this, we can, I mean, we can see most of the accidents happen because of what? The road. If the road is not good, in that case also it will happen. I mean, accident might happen, and the driver whoever driving that particular vehicle, if he's not aware of what is happening around him, or maybe he's feeling sleepy while he was driving, and he might be talking with somebody else while, I mean, these are the things that happen very very frequently, and he's not concentrating on road. So these are the human errors we can easily avoid by using the automated technology, that is AI, artificial intelligence, that we can use. That has been used when it comes to Tesla. So these are the human errors that we can easily avoid when it comes to using the machine learning or artificial intelligence. How can how can machine learning able to help the transportation industry? So we have so many examples to take, but I'm taking just a few examples among those where exactly we can apply the machine learning algorithm, so that we can avoid few things. One of those things are traffic flow analysis, and one more thing we'll be having computer vision powered parking management. Using this, we can reduce the human error. We don't need to have a human resource in that particular area. Machine learning itself monitor all those things. And ensuring highly secure routes. I mean, whatever the route that we'll be having, whether the road is good or not. I mean, how would that particular, if some transport, you have one forecasted route, one route you have, and you are sending some goods in that particular route. So before that, you need to know how good that particular road is. So for that, you can deploy machine learning algorithms like drone analytics and all, drone images. Using that, we can analyze the road, whether we have good road, or do we have any cracks, or even do we have any potholes, or do we have any obstruction when it comes to road. All those things that we can monitor, and generating accurately when it comes to e-commerce websites. What happens in these are the different we'll be explaining each one by one in detail, but these are the applications we'll be having. Generating accurate ETAs. What are the ETAs? Estimated time of arrival. When exactly whatever the product that you have ordered, how much time it will take for the arrival. In the e-commerce industry, it is not it is very important to know how what is the estimation time of arrival, so that based on that only the particular consumer will order that particular product. If it is taking too much time, maybe he might be canceling that particular product in the middle. So in that case, you are the one who should bear that transportation expenses, right? So if you are giving that estimated time of arrival in the previous only, in that case, you can easily able to if it is taking 7 days of time, if he's okay with that, and then only he can order that particular product. And predicting the vehicle breakdown. And this is one classic example that I have discussed in the very first slide. How long that particular vehicle engine will bear all those things. How long it will take to break down. If you have the data, in that case, we'll be discussing in detail. And expediting the resolution of delays. How much delay it will take. It is similar to the expected time of arrivals. And automated license plate recognition. If you have, so many countries are already using this automated license plate recognition. That could be helpful for crime detection. And to know, if somebody, violating the rules of traffic. In that case, also we can use that automated license plate detection. It is also work based on the CV. Computer vision technology only. We'll be deploying the different CCTV camera footages. Based on those footages, we'll be using the computer vision technology to determine the particular license plate recognition. With that, if we know the license plate, in that case, we can easily figure it out, right? Who's the one, something like that. Driver monitoring. So we can deploy one more algorithm, that is CV, that is computer vision technology, to monitor that particular driver, whether he is doing good while driving or not, or making some mistakes or not. We'll be discussing in detail. Before that, just look at what are the different techniques we can apply. So it is one of the we have so many examples, but I have taken what is the pedestrian detection. So how awesome it could be when whatever the machine learning algorithms you will be having, it can easily detect whoever coming across that particular road, whether that particular person is pedestrian or something in some other vehicle or not. So among when it comes to AI, artificial intelligence, if you are using artificial intelligence in different cars, most important thing that you should consider is a human behavior is very very unpredictable while going on road. So he might come from anywhere. Like it is the human nature is very unpredictable one. Whenever that particular machine or the algorithm that you are deploying into the AI driven cars, so it should right after the observing that particular human right in front of that, he should press on brakes. He might come from anywhere. That is when it is the one of the abstraction that when it comes to AI driven products, the vehicles, human can come from anywhere. So it has to capture that particular information. It has to process. It doesn't require. We don't need to capture the details of that particular person. Just need to observe whether that particular object is a human or not. We don't need to capture whether that particular person, human, who's that? I mean, what are the features? Does that particular person is a male or female? If it is male or female, whether that particular person children or not, and which particular person he is the Elon Musk or not. It doesn't matter who comes in front of that particular AI-driven vehicle, but all it matters whether that particular person is a human or not. That we need to capture. For that, we don't need to have high-end cameras. For that, we just need to have like minimal, mostly. I mean, whatever the AI driven cars now will be having, that is Tesla. It doesn't care who came right in front of that particular car, but is that particular person is human or not? For that, we'll be training the machine learning algorithms based on. We'll be supplying like millions of data of different people's, side angle, front angle, and how does particular human look like from the side. So we are not capturing the details, but we are just capturing the motion. I mean, even though just skeleton like structure that representing the human, that also can go. So mostly the Tesla cars use this kind of technology only. It doesn't care who in front of it, whether is that particular person is a pedestrian or not. That we have to observe. And when it comes to transportation analytics, I mean, okay, it is one of the example whether that particular route that you will be having using the drone analytics, you can find out whether you have any cracks on that road or not, whether you have any potholes or not in that particular roads. That we can deploy some machine learning algorithms when it comes to drone analytics, and you can find out. You can see the cracks that are present on the roads, and if you have any potholes also, that easily can detect, and it will give you information to that particular vehicle, so that if your vehicle or the transportation is going on by that road, you can simply take care of those data and you can work accordingly, and you can move accordingly, and so that you can avoid the accidents. And this is one of the case that is traffic flow analysis, so that you can analyze the traffic, how congested that particular traffic is in that particular area. And so if it is very much congested, in that case you can avoid. And if somebody is violating the that particular rules, you can simply figure it out who's the one violating that particular traffic rules and all those things. If somebody is violating, in that case you can simply capture that information or that number plate, and you can easily process. Haven't discussed this in detail. We'll see where exactly we'll be using the traffic. So what happens in traffic flow analysis? It will simply capture the information that is present on that road. Based on that, it will give you the indication saying that, yeah, this particular road is congested. And if you want, you can take alternate routes. It might be taking some time. It will be giving the estimate times as well, right? When it comes to Google Maps, it is congested. And if you want, you can simply take how much time it will be taking. So time factor is very important. I mean, when it comes to traffic flow analytics, if the congested area is, traffic congestion is more, in that case, whoever driving may be feeling dizzy, he might be feeling the fatigue. So the driver might be facing the frustration when it comes to, and due to that, we can the pollution. If the traffic congestion is more, in that case, pollution also high. So if you analyze these kind of data, you can avoid traffic congested area. And when it comes to computer vision power parking management, in that case, we can simply avoid whatever the human monitoring system will be having. We can simply avoid that, and computer vision powered computer vision technology itself monitor which are the places will be having empty. Let's say you have seen the previous slide. what are the places we have empty, how many places we are empty, how many places that are has been occupied. So whichever the vehicle is coming for the parking, we can simply display saying that these many cells are empty now, and you can enter, and uh, how much time that particular vehicle has been parked in that particular place. All these things, even though if you have a human that monitoring all the system, he won't be able to figure it out all those things. But if you apply the computer vision powered parking management, it will go through all this data and it will calculate based on the, I mean, cameras only. We'll be using in computer vision technology, we'll be using the cameras, and based on that only we'll be finding out all these details, how long that particular vehicle has been parked. I mean, based on that also we will be doing the charges, right? How long it will be, parked. Based on that we'll be doing charges. So that also we can find out how many we have, how many spaces we'll be having, how many has been occupied. All those things we can do using the computer vision power parking management, on whether that particular parking has been done, is it done proper way or not, and if somebody has been violating anything like that, all those things data we can. And ensuring the highly secure routes, whatever the routes will be having, we have to analyze that particular route before sending in any goods. So see, goods plays very important roles when it comes to, the timing, how much time it is taking. It will literally decide the economy of that particular country. If it is taking too less time for the good transportation, in that case, so transportation, high, in that case, the fastness, it will decide the economy of that particular country. So even IMF, global companies also do the prediction saying that how much time it will be taking for the good transportation in each and different countries. Based on that, also they will give ranking for the development of different roads. Those ranking also it will be given by larger institutions, and generating the accurate details. When it comes to e-commerce industry, it is not just about delivering the products, full delivering of products. It's not just about that. It is also in how much time you are delivering, how fast you are delivering. How can we find out this ETA? Estimated time of arrival, how can we decide? So let's say if you have already passed some delivery product from that same route, and if you have a historical data, about that, in that case you can easily estimate how much time it will be taking, how much time it will take to deliver that particular product. Based on that, this competitive environment, competitive market. So it is very crucial to tell that particular customer how much time it will be taking for the delivering of that particular product. Based on that, like if you have delivery time is less, in that case, people are more likely to buy, because everybody want that particular product to be delivered as soon as possible. And if you have an estimated time, and in that case, they will decide whether they have to go with that product or not. So you can avoid so many losses as well when it comes to this. And the resolution of delays, expediting the resolution of delays. So if you know that particular route, if you have past history of that particular route data, in that case, you can easily analyze how much time it will be taking, how much delay will happen. All those details you can simply provide to that particular customer, so that they can analyze that particular data. Based on that, they will take the decision whether it should go for that particular or not. And license plate. So when exactly we'll be using the license plate recognition. So it will be used in different scenario. If somebody is violating the rules, in that case, this license plate will be linked to that particular person, right? The person who purchased that particular vehicle. If some violation is happening, in that case, what happens? You can simply capture that using the CV only. We'll be using here. We'll be using the computer vision technology only. And if some crime has happened, if somebody stole that particular any thing in, and he's passing, I mean, he's using some particular vehicle, and if you want to track down that particular vehicle, in that case also we can use the license plate recognition. And if that particular person violating any, obviously violating some traffic rules, or violating, I mean, whenever there is a green signal, if it is violating that, in that case also we can simply capture that information, and we can send the details to that particular headquarters, so that we can punish that particular crime, I mean criminals, I mean whoever doing that particular crime. Driver monitoring. See, this is the one of the important thing when it comes to nowadays. Driver never admits that he is careless when it comes to driving. So what we can do, instead of just relying on the driver itself, we can simply apply one AI-driven model, the camera, that we can simply deploy machine learning algorithm on that particular camera, and you can deploy on the vehicles. What we will do, it will simply capture the information of that particular driver who were driving, whether he's feeling sleepy, or the emotions of that particular driver will be captured by that particular camera. According to that, it will give the indication saying that, yeah, you might be feeling tired, you might I mean, if that particular driver is dizzy, in that case what we'll do, it will simply give indication that you are dizzy, it better take some rest, and then you can start working on it, something like that. And if that particular person is drunk, and some vehicles nowadays they are deploying in if to test that particular person has drunk or not. If that particular algorithm is sensing some alcohol right before starting that particular vehicle, we have to use breath analyzer. And if the machine, I mean the algorithm is sensing alcohol percentage in that particular person, in that case that particular machine won't start at all. So these kind of algorithms will be deploying when it comes to different machines, to avoid the unnecessary accidents. I mean, there are so many people losing their lives just because carelessness of others. So we can avoid these kinds of things using the machine learning algorithms when it comes to transportation. So these are the examples we'll be having, and different. Yeah, and the final conclusion when it comes to artificial intelligence, where exactly we'll be using this artificial intelligence. So obviously, artificial intelligence, or you can also call it as machine learning, leveraging important advanced technologies such as big data in transportation for improved safety. So using the machine learning algorithm, we can improve the efficacy or efficiency of the transportation system. So in that case, we can avoid so many accidents, number of road accidents, improve the flow of traffic, and even bring the criminal to the justice. So these are all the advantages we'll be having, and it is just a beginning. And when it comes to the machine learning algorithm, and as technology continue to improve, the more smart technologies will be coming across, and we can deploy those models into the action, so that we can improve that particular the same transportation efficiency we can improve, and enhancing the sustainability and making our roads better. So these kind of improvement that we can do when it comes to machine learning algorithm, using the machine learning algorithm as well as AI. So these are the conclusions we'll be having. When you are able to address all the key issues that are blighting in the transportation industry, such as huge number of needless deaths you can easily avoid, and damaged roads will be having, that you can avoid. Like, these are the different things that we can avoid using the machine learning technologies. So this is the applications of machine learning algorithm when it comes to transportation. We'll be having so many other transportation applications as well. But since time constraint, I'm not going through all those things. You might be coming across so many other applications as well, like There are so many applications you might have come across. And when it comes to use cases, guys, what are the transportation use cases we'll be having in the coming classes? We'll be discussing about the data mining and what are the different algorithms we'll be having when it comes to machine learning algorithms. And each algorithm will be taking one use case scenario and we'll try to apply. Like I have explained you in the very first slide, what are the different algorithms we'll be having and mathematics behind that, and we'll be using one use case scenario so that you can understand end to end what is the mathematics behind that particular algorithm and where exactly I can use that particular algorithm in real time. So if you want to know a bit, more about this transportation analytics, and if you want to learn in that case, keep continue with this series. Yeah, that is it all for today, guys. And if you want to kickstart your data science careers, in that case, you can simply go through our 360DigiTMG channel, and irrespective of your domain, almost we have covered over 30 domain analytics that we have already covered. If you are interested in any one of those domains, you can simply go through 360DigiTMG's YouTube channel, and you can find all the domain analytics videos. And if you want to learn things when it comes to transportation, please continue with the series, and we'll see you in the next class, guys, and have a nice day.